This is problem 16 from the spring 2015 AMATYC Student Math League's math contest. This says Cal plans a trip from Seattle to San Francisco to Los Angeles to Las Vegas and return. Between Seattle and San Francisco and Los Angeles, he can go by car, bus, plane, or train. But between LA and Las Vegas, he can go only by car, bus, or plane. And how many ways can he select his mode of travel so that at least one of the return legs uses the same mode of travel as the corresponding outbound leg? So it turns out this is a relatively straightforward counting question here. There's a little bit of a trick here, but somewhat nice here. Let's just draw a little diagram here. So we're going to start in Seattle, and then go to San Francisco, and then go to Los Angeles, and then go to Las Vegas, and then we're going to go the same trip in reverse. So I'm going to go back to LA, back to San Francisco. I'm going to draw just a separate Seattle here, although I could have looped that back up to the original Seattle. And then the number of options we have is, okay, between Seattle and San Francisco and LA, that's going to be these four. Presumably both ways are the same. Go by car, bus, plane, or train. So there's four options here for each of those. But between LA and Las Vegas, he can go only by car, bus, or plane. So no train. So we get 3 each here. We want to know how many ways can he select his mode of travel so that at least one of the return legs uses the same mode of travel as the corresponding outbound leg. No idea why you'd be particularly concerned about that, but that's what the question asks. So now we could, start to think about, are these two legs the same? Seattle and San Francisco, LA the same. Start adding those up. That gets a little bit messy. What's going to be easier to do here is to talk about, let's say, number of ways. Let's see, what am I going to say? At least one in-out pair the same. That's really what we want. And when you have this at least one of something, there's sort of a common trick where you can rewrite that as sort of total number of ways minus the number of times that this can't happen. So if it's not the case that at least one in-out pair are the same, that's going to be the number of ways where all of the in-out pairs are different. Number of ways all in-out pairs are different. So that's really the trick here as we do this. Up here. And so what we're going to get when we do that, let's see, total number of ways we can do this. Well, it's just going to be choose 4, choose 4, choose 3, choose 3, choose 4, choose 4. It's going to be a straight multiply. 4 options for the first, then 4 for the second. Can still do anything. LA to Las Vegas, back to LA, back to San Francisco, back to Seattle. So that's the total number of ways that we can do this, paying no attention to sort of matching or not matching in and out routes. And now if I want all the in and out routes to be different, well, I can choose 4, 4, 3. So I've got 4 options, 3 options. But now when I go from Las Vegas to Los Angeles, I have 3, but I already used one of them. I don't know which one of those it was, but it doesn't really matter. There's really 2 choices left. And then the next one, let's see, there's 4 options, but I used one of them from San Francisco to LA, so I really only have 3 options left. And same thing here for San Francisco back to Seattle, 3 options left. So really, this is going to be our answer. We just need to calculate that. What I'm going to do is, I noticed there's 4 times 3. Here's the same, and actually another 3. Well, I was going to simplify this, but you know what? We're going to use a calculator. Let's just crank this out here. 4 times 4 times 3 times 3 times 4 times 4. Total number of ways is 2304 minus total number of ways where every pair in-out is different. I get 864. And so that leaves me with 2304, minus the 864 gives me 1,440 ways where I use at least one of my legs as the same in and outbound pair. So 1440 is my answer, and that is C. There we go, and that's our answer.